Alright, page 2 of the review starts at number 4, and it's just asking, is it a factor? And to find out it's a factor, we can do one of two things. Either we can plug a in, and a in this case is 3, because remember, it's always x minus a. We could plug 3 in. I'm going to do the math quickly here. 27 minus 9 times 2 is 18, minus 15 plus 6. I'm going to get 9 minus 15 is negative 6 plus 6, and I get 0. If we get 0, that means yes, it's a factor. The other way to do it is by using synthetic division with the same a into the same things. And what you'll find is this is easier. Sorry about that. We always drop it low, multiply, add, multiply, add, multiply, add. And again, if I get 0 as my remainder, then the answer is yes. If I do not, it's no, which, little hint hint, might work out here. Again, you could plug this in, but I think people make mistakes here when they multiply it through with negatives and positives. What I'm worried about is people calling this negative 1 to begin with, calling this minus 2 because that would be positive, and instead I'm afraid people will zip zap that. This is a zip zap, so that has to be a plus 5, plus 6. It's just a lot of places you can make mistakes. If you use synthetic, you get the same result. The fact that I don't get 0 here is all I need to know the answer is no. It doesn't matter what else it is. And again, I can add this up. 11 minus 3 is 8. I still get it. Either way is acceptable. Okay. For number 6, now keep in mind here on this problem, you have a missing term. And the missing term is right there. And we need a placeholder when we do synthetic to do this. Now again, do you want to plug negative 2 into this? You're more than welcome to, but it is way easier if I use synthetic, as long as I remember that I have to have a placeholder. So this is my x to the 4th, x to the 3rd, x squared, x, and then my number. Okay? I'm going to have on the test hint missing term as well to help you remember it. Drop it low, multiply, add, multiply, add, multiply, add, multiply, add. And the answer is negative 49. Again, if you plug it in, I'm not even going to do it on this one. You can still get that. It's just a lot more work. Down at the next step here, all we need to do is factor. So factoring just means something like that. Okay? And look for GCFs first if you can. Nothing to pull out here. This is a very simple x and x, the factors of 72 that add up to get 6. You might go through a few. 8 and 9 is probably the first one you think of. There's 4 and 18. That doesn't give me 6. 6 and 12. Yep, there it is. 6, 12, positive, negative. Done. For this problem, there is a GCF. It's not 6, it's 3 and x, because I can pull a 3x at all of these. Now keep in mind, what you're doing here is you're dividing by 3x for each term. So here I get a 2x squared left. Here I get a 5x minus a 12. And I need to completely factor it, which means I have 2x and x. I'm not going to give you something that doesn't, not in this part. And I need to figure out the factors of 12 that when I multiply the inside and the outside are going to give me 5x. So the first thing I think of is 6 and 2. Well, if I put 6 here and 2 here, I get 4 and 6. That won't give me it. If I put 6 here and 2 here, it give me 12 and 2. That won't give me 5. So what about 4 and 3? If I put 4 here and 3 here, I get 6 minus 4. Nope. If I put 4 here and 3 here, I get 8 and 3. Yep, that's what I need. This gives me 3x. This gives me 8x, as long as the 8 is positive. So I like to put signs on both of these. And the 3 is negative, it'll work. Okay, well this will give me negative 3, but this, I would need that to be positive. And there's my answer. A lot of thinking there. Same thing here, GCF at first if you can. 3x comes out, 4x squared minus 9 times. That you should recognize as difference of squares. 2x and 3. One's plus, one's minus. This is the AB problem, okay? And so is 12. So I'll just put that down here. AB, A squared, AB, B squared. We will likely have this on the board for you. When it's positive, it's same, opposite, plus. When it's negative, it's same, opposite, plus. So for this problem, I got x and 5. That's the cube root of each one of those. X squared, 5 squared, multiply the two together, same, opposite, plus. Notice I don't do the signs until the very end. I don't want you to either, because I don't want you to think of that as a -5 and then have a negative here. That's not the way it works. 27, the same kind of thing. 27 is 3x and 5. Probably should have showed something besides 5, but oh well. 3x squared means 3x times 3x, which is 9x squared. 5 squared is 25. Multiply 2 together to give me 15x. Same, opposite, plus. Done. This you would solve just like an x problem, and the factors of 12 are 4 and 3, and it'd be minus and plus, and the only difference here is because it's x to the fourth, this is squared and squared, and the reason that's significant is because this can be factored further. X plus 2, x minus 2, so that goes here, x squared plus 3. Okay. And that's the factoring section. I'm going to move it down here. Make sure I don't skip anything today. The number of roots is equal to highest degree. And so this has a 4, so there's 4. This should be a really, really easy one for your test. 2 gimme points. This is 7 as well because the highest exponent is 7. If you remember this section, you might have to go back and look at this. This was from 6.6. Anything that has a square root or an I also has the other root, the plus and the minus part. So 2 never gets it. That's already one by itself. But this, I would get 3 minus the square root of 7 as a root as well. We went through the proof of that by giving you an example, but not need you to do that. You just need to recognize that whenever I see an I or a square root, it is also its opposite, but not when it's a whole number. If you give me -2 here, you're going to lose a half a point. This will give me 4 plus I. This stays as is. It's a whole number, and I just get those solutions. Down here on 18, we're going to factor each polynomial and then solve it. So here, this is difference of squares, 4x and 7, 4x and 7. If I can square root both terms, it's difference of squares. Even up here, I square root those to get the x and 2. Plus and minus. Because I'm solving, that means set factors equal to 0. So I set 4x plus 7 equal to 0, 4x minus 7 equal to 0. Here I would subtract 7. Here I would add 7. And in both cases I divide to get x equals -7/4 and +7/4. If you wrote plus or minus 7/4, it's the same thing. This problem looks harder. It's not. It is factorable. I wouldn't give you something that's not. And 5 is a prime number. So I can start off with 5x and x no matter what. Now again, I got to find the factors of 6, 2 and 3, or 1 and 6 that will multiply together to give me 13. If I put 6 and 1 here, 11 and 1 does not give me 13. So it has to be 2 and 3. Well, if I put 3 here and 2 here, this will give me 2x and 15x on the outside. I need it to be positive and negative, so I put the signs here. Check it, -2, nope, I need that to be positive 15. And now again, set each one of those terms equal to 0. Here I might add the 2 and divide to get 2/5. Here I would just subtract to get -3. This is again x squared, similar to earlier. I've got the factors of 9 that give me 8 are obviously 9 and 1 minus plus. This I can take further to x plus 3, x minus 3, and x squared plus 1. Set each one of those equal to 0. I get 3 and -3. Opposite. This would be -3. That would be 3. If I set x squared plus 1 equal to 0 though, I would minus 1 to both sides. And then I need to square root it. And the square root of -1 is I. But remember, anytime you take a square root, it's plus or minus. So I get 4 answers. Now there should be 4 answers, just like we said here. There's number 7 roots because it's to the 7th power, 4 roots because it's to the 4th power. Well, then I should get 4 answers here. 1, 2, 3, 4. I should get 2 answers here. I should get 2 answers here, and I do on all of those problems. There's page 2. Page 3 is coming.